Okay. Okay, this is dissection of the eye, and first off, this is actually a cow eye, and I've already dissected a lot of the muscle and the fat off from around the eyeball itself. And I always tell the students, cows only have 4 muscles, one on the top and bottom and one on each side. We actually have 8 muscles around our eyes, so the students can roll their eyes at me, but the cow can't. I know, gotta have humor, right? Anyway, so if we look at the eyeball, and like I said, I've taken the fat and muscle tissue off the eyeball already. So if we just look at the eye, here's looking at you, right? Anyway, the front of the eye is called the cornea, the window to the eye. So that's that front part here. The cornea runs right in conjunction with the whites of your eyes. That white tissue around your eyes is called the sclera. And the sclera is a white fibrous tissue. Everything attaches to it, the muscles, nerves, vessels, all of that. But the sclera, not only the whites of your eyes that you can see out front, it runs right around the whole eyeball. And then the sclera runs right, not only your whites of your eyes, the whole eyeball, it goes right down the optic nerve. The optic nerve is that nerve that comes out of the back of the eye and takes the sensations to the brain to be analyzed. And so the first parts of the eye, of course, we have the cornea, then we have the sclera, the white part of the eye, which covers the rest of the whole eyeball, and then the optic nerve that comes out the back. So the first thing we're going to do is we're going to dissect the eye in half and see the inside structures. Right behind the cornea, you have a chamber in between the cornea and your iris that has aqueous humor in it. So it's watery like fluid, it's aqueous humor, and we can never really see that because as soon as I breach the cavity of the eyeball, the aqueous humor comes out. And so I'm not going to hold real tight pressure either, but we want to start right here. We want to cut the cornea and right sclera and try to cut the eyeball right in half. So let me breach the cavity first. I thought I changed the blade. I thought this would be nice and sharp, but it's not. There we go. Okay, so now I'm going to dissect the front of the eye from the back of the eye. Don't cut yourself, Donna, huh? Okay. You can see these preserved samples are very tough tissue also. Okay. You probably don't have a glove on still, huh?
No.
Okay. There we go. We're getting there. Okay. So if we again look at the front of the eye, we had that aqueous humor. In the back chamber of the eye, back here, we have, you can see it's jelly-like, it's real squishy. Oh, is that recording, honey? It stopped. It's okay. So anyway, we have this real jelly, like, this is called vitreous humor. It is gel-like. It will let the rays through. However, it keeps the shape of the eyeball. Okay, if we look at the front part, and so we have some of that vitreous humor still, so we'll take out some of that vitreous humor, and I know the students always love that. It's like gel part that's like kind of, look. Anyway, then I'm going to turn this right inside out, and you can see you have that colored ring, your iris, that's the color of your eyes. The iris is actually a smooth muscle, and that's what, of course, allows your pupils to constrict and expand. And if you're really good, I haven't done this in a long time, but you can cut right through the colored part, the iris, and maybe remove it. Haha, so we can see. But remember, the iris is actually smooth muscle, not only the colored pigments that make the coloration of your eye, but it's a smooth muscle. Okay, and of course the only other thing we have in the front was the cornea, the window to the eye, and the sclera. But now if we look in the back, we actually have, this is called the lens, and the lens is actually suspended right behind your iris. It's going to focus incoming rays on the retina, and the lens is actually very bulbous. It's kind of clear, And I will try to dissect that right in half for you. And you can see, you can hear it go crunch. It's actually very granular, but the lens is important in focusing and vision. So then, if we look on the back here, we have again that vitreous humor, that gel-like humor. But if you can see, all curled up in there is a thin brown membrane. That's actually your retina. And the retina that is that thin brown membrane behind the vitreous humor, it's made up of your photoreceptors. You have two kinds of photoreceptors. First, you have rods and cones. The rods are for black and white vision, and the cones are for color. And at least that's easy, right? Cones for color. So that'll be a question you'll need to know. Rods are for black and white, and cones are for color. And so now maybe we can take that vitreous humor, but the retina is such a thin membrane and it's so delicate that I'm just going to take it out on the back. Now see, it's attached right there to the back of the eye, and where it's attached, of course, goes down your optic nerve, and you don't have any rods or cones right at the optic nerve, so that's your blind spot. And I always think there's a test, and I never remember it, that you can put a pencil in front of your eye and where you can't see it at your blind spot. But anyway, the other question that's always asked is, you have this nice shiny inner membrane. That's because this is a cow eye. So outdoor animals, a lot of them have this reflective membrane. We don't have it. But that's why when you shine a light in eyes, it reflects back because they have the membrane. But anyway, so now if we just look back at, you can see your retina. That's such an important structure, and it's so thin and so delicate. No, I'm not going to be able to get it off the vitreous humor, but that's okay. So along here, again, I want you to remember the aqueous humor is near the front of the eye. The vitreous humor is the gel-like in the back cavity. The retina is the membrane with the photoreceptors. You have your rods and cones. And of course, you have your iris, the colored part of your eye, and the lens that's the focuser that's going to take the incoming rays of light and focus it on the retina to be able to have vision. And so much for the eye. We're done.